Good morning from the National Weather Service in Raleigh, Nick Petro, with your 11:30 update on this Saturday, 17th of January. So this kind of light winter weather event is pretty much on track with what we talked about yesterday. So I'm going to go ahead and just jump straight to my display here, showing the current situation. And all right, so what we've got here, a couple things I'll point out. Number one, we did have a band of that light rain. Remember we talked about it yesterday with that initial front, and it's mostly already dried up here across the most of the Piedmont. This is live radar data, with the only rain still left from that band is up here in south central, southeast Virginia. So it's mostly dried up across central North Carolina. And yeah, that's that initial batch of light rain with that initial front that we talked about. Okay, and you can kind of see it in the temperatures. These are surface temperatures. And I bet you if you're following along, where do you see big changes in temperature from west to east? Well, you see temperatures here in the 60s versus temperatures in the 40s, 40s versus 30s. So there is an air mass change kind of right there. But if we go back further west, where else is there an air mass change? There's a little bit of an air mass change here, but not really. Going from 37 to 44 isn't really that big of a change. But when you go from single digits and 20s to 30s, that's kind of a big change. So there's a sort of a secondary front right here, an air mass change, right? And so those are our two current air mass features, right? You have this initial front, but it's still kind of warm back behind that first front. It's very warm ahead of the first front. Okay, so, but it's still kind of warm back here. So we're not seeing a huge cold down during the day today. In fact, temperatures are going to be not too bad. This whole weather system tomorrow is dependent on this air mass moving eastward and catching up to the rain that will be moving across. So let me remove all my drawings here, and then I'm going to sort of zoom out. And again, you could see that change in temperature, that first boundary, and then here's kind of a secondary bigger change. And as I put on here simulated radar, this is live radar, okay? And let me put simulated radar on here, and I'll just remove the live radar just to avoid confusion, okay? And I go forward in time, you can kind of see what's going to happen, right? Eventually with time, this actually, let me remove my drawings here just to avoid confusion. The rain sort of fills in from the south, okay? So this time right here is this evening. This is basically midnight tonight, and this is overnight tonight, okay? So you can see that all this rain down here over the Gulf Coast will lift northward with that wave of low pressure that we've been talking about along the boundary that's kind of stalled over us right now. Meanwhile, that rush of cold air that's basically along and west of the Mississippi will be surging eastward with time overnight tonight. And you can almost see that in the simulated reflectivity. If this is current time right here, and then watch how the blossom of precip comes up from the Florida Panhandle, and then that gets in here. And then you can see right in this time frame right here, this is 7 a.m. tomorrow morning. Look how it turns blue and purple on the back side. That's the transition to snow. But if I go back in time, you can almost trace that blue back to what's happening kind of in the Mississippi Valley. So in other words, what do we got going on here? We've got a batch of rain coming up from the south, and we've got cold air rushing in from the west overnight tonight. The challenge with this type of weather scenario is how much precip, how much moisture is left by the time the cold air gets here. So let me run you through this here real quick one more time. This is basically current time. This is midnight tonight. This is overnight tonight. So patchy rain's gonna break out across all of central North Carolina, overnight tonight. Is it enough to wash the brine away? It could be. We could start this out as a rain event, so some of that brine might get that you see on the streets might get kind of washed away. It just really depends on how hard this initial rain is. It's hard to say if it's going to be hard enough rain to wash it away. But anyway, we're going to start out as rain. Just about everywhere is going to see rain overnight tonight. But then that cold air comes in. This is 7 a.m. tomorrow morning. This is 10 a.m. tomorrow morning. This is 1 p.m. tomorrow morning. This is 4 p.m. tomorrow afternoon. And this is 7 p.m. tomorrow. So by 7 p.m., everything, regardless of the type. Oh, let me remove these temperatures again, just to avoid confusion, because those temperatures are live temperatures. So anyway, by 7 p.m. tomorrow evening, it's all gone. Rain and snow, no matter what it is. If it's all rain, and then all the rain's gone. If it's a rain and snow mix, all the snow, everything's gone. All precip types by 7 p.m. Okay. But the details, the models are still struggling with the details in terms of the timing of that arrival of precip, and how much might stick, if you will. So anyway, I've got two different simulations here again to show you timing, and you can see the timestamps are up at the top. And as I take you through this, they're two different models. The high-res rapid refresh on the left, and the NAM model on the right. And you can see there's 9, 10, 11 o'clock today. There's that light rain that's basically in the process of dissipating. So we should be dry from here on out the rest of this afternoon, maybe save for a few isolated sprinkles here and there, but not much. Okay, now as we get into the overnight period, look how this is 11 p.m. tonight. Look how the rain breaks out across central North Carolina, at least in the model on the left. That's 1 a.m. And then you could see, even on the model on the right, what does come in from the west does start as rain. But then on the model on the right, look how quickly it changes over to snow by 5 a.m. across the triad. So if you're in the triad, the colder of the two solutions suggests that it'll be snowing by 5 a.m. prior to sunrise tomorrow in the triad. But the warmer solution on the left suggests maybe a mix of rain and snow, but certainly not a full transition to all snow. Okay, then as we go through the rest of the morning, look how by 8 a.m., everywhere pretty much west of the triangle down to Wadesboro is changed over to snow, where on the model on the left, only a few patches of snow are mixing in. You see, my point is that the model on the left is taking much more time for that cold air to filter into the area, so it hangs on to the rain longer. Okay, so if it takes longer for that cold air to get here, then we're going to stay rain longer. But if that cold air surges in and it's quick, then we get a quicker changeover to snow, as the model on the right would suggest. Okay, and then as we continue this simulation, by 10 o'clock, pretty much from the triangle westward, it's snow, as the model on the right would suggest. And then as we continue, the snow makes it to I-95 by noon, whereas the model on the left is pretty much, mostly rain throughout. Maybe on the far western fringes it mixes with a little bit of snow, but certainly this is the model on the left is much warmer. It just takes longer for the cold air to get here on the model on the left. Okay, and then you can see as we go through the afternoon, that snow, and this isn't going to be heavy snow. This is just going to be off and on. It will be, offset by the time, by the fact that it's falling during the daytime. It's always harder to accumulate snow during the daytime. Let's just say if the model on the right was correct, I still wouldn't expect, you might look at that and say, well, gosh, it's going to be, snowing for, 6, 7, 8 or more hours in a row. Well, that's usually not the case. Usually it's kind of, off and on, and anywhere there's accumulation is rate dependent. Okay, it's driven by rates. In other words, if it's snowing real lightly and it's happening during the daytime, that snow is going to have a tough time accumulating. But anywhere in sort of these banded nature, anywhere it comes down harder, where, the visibility lowers and you can't see very far in front of you because it's snowing so hard, those occasions which again, it won't be all afternoon, but where and when it does happen, that's where the better chance for accumulations will be. Okay, let's take this continued forward, and by 5 p.m., it's really starting to sweep out of here. By 7 p.m., the whole thing's gone. Okay, so I just wanted to show that simulation, because that conveys the idea why this forecast is so challenging, and why, you know, this still could go either way. We may not end up with anything. You know, if the cold air takes a long time to get here, but if the cold air rushes in really quick, then we have more of a longer duration in which we see snow on the back end. Again, it'll be rate dependent, so any accumulations will be where the snow is coming down harder. Okay, so how do we get an idea of how much this is going to amount to? Okay, let's start out at weather.gov/Raleigh. Okay, so you start there, you scroll down to where you see winter weather, you click on that little winter weather tab, and then this takes you to our probabilistic snow amounts. Okay, so the one on the left is our official forecast. So our official forecast, as you could tell, sort of leans towards that warmer solution with lesser amounts, mainly trace to under an inch of snow. And you can see the areas where we think the best chance for this trace to a dusting to maybe upwards of an inch of snow could occur, mainly, you know, from Raleigh north and westward, up near the Virginia border. You know, up near the Virginia border, it seems like, you know, it always trends towards colder. It's just, that's just climatologically along and north of I-85 and up towards Roanoke Rapids. Climatologically speaking, that's where it's always the location that has the better chance to see snow and higher accumulation. So if you're north of 85 and up near Roanoke Rapids, northern I-95 corridor, yeah, you're probably going to see the higher end of this range, okay, probably closer to an inch. If you're down near Wadesboro, Laurinburg, Fayetteville, you know, you may not see anything at all in terms of snow, okay? So this is our official forecast. But let's say that the cold air rushes in and gets here faster, so we have more prolonged snow, and it's, you know, snowing in places and times where it's coming down pretty good. You know, there could be 1 to 2 inches of snow that accumulates in the areas where you see that that darker shade of blue. You see that third shade of blue, like around Henderson. There could, the point of that, we're not saying that Henderson's going to see the most snow this entire event, but the idea is that there could be embedded pockets, little islands, if you will, of heavier snow, 2.5 inches of snow, you know, if that colder solution comes to pass. So again, this is the colder solution. So 1 to 2 inches, basically along and south of Highway 64. Okay, I'm going to do a really rough approximation of Highway 64. Okay, so when we say along and north of Highway 64, this is the general area we're talking about, northern half of central North Carolina. Okay, is the locations with the best chance to see 1 to 2 inches of snow. If you're south, you're you know, and the cold air does rush in, you could see upwards of an inch. Okay, so again, you know, maybe a pocket or two, particularly north and east of Raleigh, could have a chance to see a little more than 2 inches. But again, this all assumes that the colder solution verifies, where the colder air rushes in quicker. Okay, so that is kind of the high end amount, or worst case scenario as we call it. If you go down and you look at this low end amount, that just basically says that, you know, there's at least 10% of the models that showed nothing at all falling. Okay, nothing, 0. Okay, and that's that warm solution that I was telling you about. Okay, so those are the amounts. The official, you know, a trace upwards to a ½ inch, maybe some spots seeing upwards of an inch. Again, from you know, Asheboro to Durham to Lewisburg to Roanoke Rapids northward. Okay, if the colder solution verifies, the northern half of central North Carolina sees 1 to 2 inches of snow. You know, some pockets, some islands, if you will, of 2 to 3 inches. Where the southern half of central North Carolina, a ½ inch, maybe up to an inch. Okay, and again, this would be mostly a daytime event. If you're out towards the Triad, it starts even before daytime. That snow, again, given the colder solution. By 7 p.m. tomorrow, it's out of here. Okay. So so that's what we have for you. Let me just take you through the slides real quick. You already have this in your inbox. I've already conveyed all of this. I've conveyed all of this, and I've showed you this and how to get to that. This is just the probability of exceeding the amounts. The bottom line here is areas across the northern half of central North Carolina have the better chance to see snow. That's what these maps are conveying. Okay. Let's also remind folks that you know, that cold air, once it gets here, it's going to continue dropping the temperature overnight tomorrow night. So we'll have to be cognizant and aware of patchy black ice Monday morning, especially where the heavier snow fell. So keep in mind, it's going to get really cold tomorrow night. So watch out for that patchy black ice Monday morning. Okay, so we have this timeline here to kind of just convey that, you know, most of the impacts and most of the weather hazards are going to be confined to daytime tomorrow and to tomorrow night. Monday, things should you know, improve pretty quickly, mainly because, you know, this is a low end amount. Okay, so fairly minor, I would say, overall impact, and fairly compressed into a Sunday night time frame. Okay, so that's what I have for today's update. And bear with me here for just a second.